13.8 billion years passed. The universe sprang from a solitary point in space, known as the Big Bang, the prevailing theory behind our universe's inception. Scientists formulated this narrative upon observing all galaxies moving away from us, hinting that everything might have once been compacted into an infinitely dense singularity. This singularity was intensely hot. Another sign of the Big Bang is the cosmic microwave background, residual radiation from our universe's early days, visible only through telescopic aid. But what if our grasp on the universe's beginning is flawed? What if there's more we've misunderstood? Where questioning established notions could upend our comprehension of the universe. Despite not eagerly anticipating the universe's end, examining its eventual demise might challenge your understanding of its origins. Before we unravel the mysteries of the universe, let's talk about something serious. March is Mental Health Awareness Month, and it's time to fight the old stigma that you have to struggle in silence. Especially when 40% of American adults report living with symptoms of anxiety and depression. You know, on average, it takes about 11 years for someone to seek treatment after symptoms occur, mostly because people can't afford help. Now, while these numbers are scary, it does mean one thing: you're not alone. Right now, this administration is working to make mental health care more accessible, like through schools, expanding telehealth support, and providing more funding for CDC programs. Let's break the silence. And if you're in need, check out the resources available to you in your area. The universe is a lot better with you in it. Okay, so you know that our universe is continually expanding outwards. So you might assume that it would likely continue expanding forever. Well, this could be true. And this is why the most widely accepted theory involves the universe doing just that. It's called the Big Freeze. And what's really cool about this is a mysterious and invisible force that makes the universe expand. It's called dark energy, and it makes up 69% of the universe's mass. Another 26% of it is made of dark matter, and only 5% of the universe is plain old, ordinary matter. If all this material originated from one point and just kept expanding, eventually all this heat and energy would be very, very spread out. At a certain point, everything would be so far away from each other that the entire universe would reach a ridiculously frigid temperature. Absolute zero. Absolute zero is the lowest temperature possible. It translates into 0 Kelvin. Or if you prefer, a more familiar temperature scale, minus 273 degrees Celsius. By the time the universe reaches this super low temperature, you wouldn't be able to see any distant galaxies from your vantage point in the Milky Way. Don't worry though. In a few trillion years, there's a projected eventuality, although it's just one among various theories. Another possibility regarding the fate of the universe is diametrically opposite to perpetual expansion. It entails a grand reversal known as the Big Crunch. This scenario suggests a collapsing, constricting fate for the universe instead. The cumulative mass of all cosmic matter possesses an unfathomable gravitational pull, potentially capable of counteracting the elusive force known as dark energy. Should the Big Crunch materialize, the universe would undergo an inward collapse. At vast distances, galaxy clusters would gradually coalesce, while closer to home, stars and planets within our galactic vicinity would clump together, intensifying the density of celestial bodies and consequently raising the temperature of the cosmos. The resulting heat would far surpass the radiance of stars, reaching an astonishing 5,000 degrees Celsius. Such an escalating thermal environment would plunge the universe into a state of scorching turmoil. As temperatures continued their relentless ascent and more mass became densely compacted into an exceedingly minute space, the very fabric of atoms would disintegrate, culminating in the formation of the most concentrated form of a black hole conceivable. This cataclysmic event would unequivocally mark the conclusion of the universe as we presently comprehend it. However, paradoxically, it might signify the genesis of a new universe. Such an occurrence would provide compelling evidence suggesting that our universe boasts an age far surpassing our current estimations. It would imply a cyclical narrative for the universe, where periods of violent contraction and subsequent expansion have potentially facilitated the creation and recreation of the cosmos numerous times over. You wouldn't have the slightest chance of surviving to witness this epic event firsthand. No one would. So for now, all of this is just an end of times theory. And it has a big name, the Big Bounce. It suggests that the universe expands and contracts all the time, just like a lung that breathes in and out. only in slow motion, and not just once or twice. According to this theory, there may have been billions, trillions, or even an infinite number of universes, both before and after ours each time the universe reforms. It could create completely different laws of physics. This would create all kinds of strange possibilities. There could be universes with no life, no stars, and not even an atom in sight. Now, this is all pretty wild, and it gets wilder from here. Some scientists debate that everything we know about our universe is wrong. What we know about the cosmos is based on what we can see and study in our galactic neighborhood. Then we assume that it works like that everywhere else in the universe. The idea is old, and it's called the cosmological principle. What we may have been wrong all along. It could be that the way our Milky Way galaxy moves through the universe is distorting our data. I mean, we've never had any hard evidence to confirm our theories, so there's no way of seeing the bigger picture from where we stand. This is where you could be starting to doubt whether any of this is real to begin with. Surely our universe, the one we can see, must exist, right? Well, not so fast. You have quantum mechanics to thank for what I'm going to tell you next. Scientists who study quantum mechanics theorize about the nature of the universe on an atomic level. And according to some scholars in this field, the universe must be one of two things, real or local. Bear with me here. I know this can be mind-numbing. If the universe is real, that would mean that it has specific properties like color and mass that exist even when you're not looking at them. For example, take a red ball. If it's real, the ball is red even when there's no one around to look at it. On the other hand, the universe could be local. This means that the universe can only exist because we are there to observe it through our telescopes. So if you think about the red ball again, without anyone around to observe it, it could have any color or no color at all. The essence of quantum physics lies in the idea that an object becomes red only upon observation of its redness. However, there's a perplexing condition. The universe may exist as either real or local, not both. Considering the unfathomable scale of the universe, possibly infinite, our telescopic capabilities fall short of encompassing its entirety. Consequently, certainty about the universe's true nature eludes us. Surprising, isn't it? This uncertainty is enough to keep one deeply contemplating the origins of everything, the potential destinations, and the ultimate purpose, if any. Yet, why halt at this point? Imagine the intrigue if the universe operated akin to a colossal brain. Thanks for tuning in. If you're enjoying the content, consider hitting the subscribe button to stay updated with all the latest uploads. Don't forget to give the video a thumbs up if you liked it.